Okay, so let's talk heat curves. This specific one, it says, what is the total energy required to raise the temperature of 130 grams of water from 22 degrees Celsius to 133 degrees Celsius. Please draw this change in all the parts on the heat curve provided. Okay, so this is our curve. Time is going to be here, and then temp will be up here. So let's use a pencil. Important temperatures that are always gonna be a thing are 0 and 100. Actually, technically yes, 0, but it's fine. We're gonna start this one at 22 because it doesn't actually start at 0. So our temperatures here are 22 and 133. 100 is important, so we're gonna put 100 back, and then we'll say 133 is right here. So 100, and if we had a negative number, it would be 0, but we don't. So 100 and 0, these are where you're gonna see your flat lines, your plateaus, okay? So in this case, it's gonna increase until it hits 100. In 100, it is going to plateau until it completely all boils, and then it's gonna make its way up to 133. So anytime it's sloping, it's a new phase. In this case, because it is above 0, this is gonna be liquid, okay? Because this one is now increasing as well. This is liquid. This plateau is changing from a liquid to a gas. This is gonna be boiling point. And then once it's done and it's completely boiled, it's gonna be a gas. So this will be gas. For our slopes, for our phases, we are gonna use the formula Q equals MC delta T. Okay? When it's boiling, or if we had a negative number and it was plateauing again, that would be melting. To solve this, we are gonna use these informations. In this case, we're only gonna use vaporization because that's when boiling is gonna come in. So we're gonna use the molar heat of vaporization. Had we had a 0 and it was plateauing and we were using the melting point, we would be using fusion, but we don't need it, so we're just looking at this. In the example that you got in your notes, you had to do 5 different steps. In this case, you only have to do 3. You have to do 1, 2, 3. Had you had solid and had to deal with the melting point, then you would have done 5. But we're just gonna solve for this. But for your entire answer, for your total, because here it's asking for the total energy, you are gonna get your answer from 1, you're gonna add it with your answer from 2, and you're gonna get it and add it with your answer from 3. And that'll give you total energy. Okay, so let's solve for 1. So for 1, we are solving for heat, so we're gonna keep our equation the same. Q equals MC delta T. Our mass based on the problem is 133. So 135, I'm sorry, grams times specific heat. This is ice. No, this is water, I'm sorry. Which we already know our specific heat because the other ones are given in joules, and we're talking about energy, we're gonna be using joules. So remember, the specific heat of water is gonna be 4.18 joules over grams Celsius. Okay, your grams are gonna cancel. Then we're gonna do the change in temperature. Our change in temperature is gonna be our final minus our initial. For liquid, our final is 100, and our initial is 22. Okay, degrees Celsius. So plug that into your calculator. 135 times 4.18 times 100 minus 22 is gonna give us 44,015.4 joules. Okay, we're done with part 1. Now let's do 2. 2, we are going to be using the molar heat of vaporization, okay? So you're going to start with your mass. Always start with your mass. So we're going to do 135 grams of H2O, okay? We need to convert it into moles. And the reason we need to convert it into moles is because here it says you have 40.7 kilojoules per mole, okay? So we need to convert it into mole. In order to do that, we need to use the molar mass. So water has a molar mass of 18 grams, and that'll give you 1 mole of H2O. Your grams will cancel. Now we have moles of H2O, but we need energy. So we need to use what they give us. So the molar heat of vaporization based on this is going to be 40.7 kilojoules over 1 mole. And again, remember, the reason we use 1 mole is because it says it's 40.7 kilojoules per mole. Okay? We're not done though. So here you can see our energy is in joules. Here is in kilojoules. We need to convert it to joules. So 1 kilojoule is going to give you 1,000 joules. Now we can plug this into our calculator. 135 divided by 18. 135 divided by 18 times 40.7 times 1,000 is going to give us 305,250 joules. Okay, now we got to do the last one, which is going to be gas. So we're going to be looking at this increase, and again, we're using the formula Q equals MC delta T. So our mass is the same. Our mass is going to be 135 grams. Our specific heat for for steam is always given to you, 2.02 joules. 2.02 joules per grams Celsius. And then our temperature change is going to be final minus initial. Our final is going to be 133, because that's what the problem tells you, minus our initial. Gas is starting at 100. Okay? So now you plug that into your calculator. 135 times 2.02 times 133 minus 100 equals 8,999.1 joules. Remember, our final answer is going to be the total of all of them. So we're going to do 44,015.4 joules plus 305,250 joules plus 8,999.1 joules is going to give us 358,264.5 joules of energy. And that's it.